Have you ever looked up at the night sky? It's a beautiful sight, isn't it? A dark velvet blanket sprinkled with countless tiny sparkling lights. Each one is a star, a giant ball of burning gas millions of kilometers away. We see them because they shine so brightly. They send their light across the vast emptiness of space. But what if I told you there might be other stars out there? Stars that we can't see at all. Imagine a star that doesn't twinkle. A star that doesn't burn with familiar fire. This isn't science fiction. It's a real idea that top scientists are thinking about right now. It's one of the biggest puzzles in the universe. These are not your ordinary, everyday stars. They are something entirely different, a cosmic ghost. Scientists call them dark stars. To understand a dark star, we first need to talk about its fuel source. This is the stuff we call dark matter. Now you might be wondering, what on earth is dark matter? That's an excellent question, and the honest answer is we don't really know for sure. We can't see it. We can't detect it with any of our instruments. It doesn't seem to interact with light or any other form of energy that we know of. Think of it like the wind. You can't see the wind itself, can you? But you can see the leaves on a tree rustling. You know the wind is there because you can see what it does to the things around it. Scientists see galaxies spinning much faster than they should. Based on the stars and gas we can see, they should be flying apart, but they aren't. When scientists add up all the matter in the universe, they find something astonishing. The ordinary matter accounts for only about 5% of everything. A staggering 27% of the universe is thought to be this mysterious dark matter. So we have this mysterious dark matter floating around in the early universe. We also have clouds of normal matter, mostly hydrogen and helium gas. These are the ingredients for our first stars. Normally, a cloud of gas collapses under its own gravity. It gets hotter and denser in the middle. Eventually, it becomes so hot and so dense that nuclear fusion begins. That's the process that powers our sun. But what if a cloud of gas and dark matter collapse together? The dark matter particles trapped inside this collapsing cloud would have also been squeezed closer and closer together. According to some theories, when dark matter particles collide, they annihilate each other. They vanish in a quiet, subtle burst of energy. This dark matter annihilation would have created a new source of heat inside the collapsing cloud. This gentle heat would have provided an outward push, stopping the gas cloud from collapsing all the way down. These stars would have been enormous. Scientists calculate they could have grown to be hundreds of thousands, or even millions of times more massive than our sun. They would also be much cooler on the surface than normal stars. Instead of shining with a brilliant white or blue light, they would have glowed with a faint reddish light. In the vast darkness of the early universe, it would be almost invisible to the naked eye. It would be a giant, lurking in the shadows, glowing like a cosmic ember. Because it was located at the center of a dense dark matter halo, it could continuously pull in more dark matter from its surroundings, allowing it to keep shining for millions of years. Let's put a normal star and a dark star side by side to really see the difference. It's like comparing a roaring bonfire to a huge glowing bed of coals. A normal star is a powerhouse of nuclear fusion. It is a compact, incredibly hot, and brilliantly luminous object. A dark star plays by a completely different set of rules. Its defining feature is its lack of fusion. This coolness allows it to be much, much bigger. While a normal star's life is a frantic race to burn fuel, a dark star's life is a long, slow simmer. It could potentially exist for hundreds of millions of years. The nickname for these colossal objects is quite dramatic: invisible engines of doom. There is a very good reason for this ominous title. It has to do with what happens when these dark stars finally die. When the fuel runs out, the gentle outward push from annihilation stops. The star, which could be millions of times more massive than our sun, would begin to collapse under its own weight. This collapse would be catastrophic. The entire mass of the star would fall inwards towards the center, forming a black hole. And because the original dark star was so incredibly massive, the black hole it creates would also be incredibly massive. These early, massive black holes would not just sit there quietly. They would immediately begin to feed. Their powerful gravity would start pulling in any remaining gas, dust, and even other stars in the young galaxy. So we have this incredible theory, but how on earth do we search for something that is almost invisible and existed over 13 billion years ago? The James Webb Space Telescope is our new eye on the early universe. Scientists are eagerly sifting through JWST's data, hoping to find such an anomalous object. It's really a search for a needle in a cosmic haystack. Another powerful tool in our cosmic detective kit is gravitational waves. Our detectors on Earth, like LIGO and Virgo, can hear these cosmic collisions. If dark stars created massive black holes in the early universe, these black holes would have eventually merged. Such a merger would produce a very specific gravitational wave signal. Let's imagine for a moment that we find one. Imagine JWST snaps a picture of a fuzzy red object from 13 billion years ago that perfectly matches the models of a dark star. What would that mean? The discovery would be a complete game changer. It would be a revolution in both astrophysics and particle physics. Finding a dark star would be the first real, tangible proof of what dark matter is. By studying the light from the dark star, we could learn about the properties of these particles. The discovery would also solve the puzzle of supermassive black holes. It would elegantly explain how they got so big, so fast. You might be wondering, why does any of this matter to us here on our small blue planet? The search for dark stars is fundamentally a search for understanding how we got here. It is about piecing together the complete history of the universe, from the very first moments after the Big Bang to the present day. As we stand here at the edge of discovery, one thing is certain: the universe will never run out of mysteries. The story of dark stars is just one chapter in a book whose pages are still being written. So, the next time you look up at the night sky, take a moment to think about what might be hiding in the blackness between the stars. The universe is not just the lights you see, it is a place of profound and beautiful mystery. The story is far from over. The journey is never ending. And the best part is, we are all on it together, waiting for the next amazing revelation from the cosmos.